we are still laying the groundwork to be able to draw a rough sketch of a polynomial function of a higher degree. So we just discussed in behavior. Now we're going to turn our attention to the zeros of polynomials. Okay, so in an earlier video, we ran across this term of zeros. Remember, zeros is a fancy word for x-intercept. Okay, so if you're asked to find the zero or zeros of a polynomial, it's asking you to find the x-intercepts essentially. Okay, so there's a little more to it, so let's go ahead and read under zeros of polynomials. It says if f is a polynomial function and if a is a number such that f of a is equal to 0, then we say that a is a zero of f. Okay, so that's one of the things, okay, that an x-intercept does. Okay, if you remember, if you plug in that x value into your function, the output is going to be 0. Okay, why? Okay, so say you have some crazy function and then here's your x-intercept. This point is located at some x value, we'll call it a, but the y value is going to be 0 because it's an x-intercept. It's on the x-axis, so its y value is going to be 0. Okay, so if you take this x value of a and you plug it into your function, the output is going to be 0. Okay, so that is one of the characteristics of being an x-intercept or a zero. Okay, the following are equivalent statements. Okay, a is a real zero of f. Okay, so if a is, remember, this is going to be an x value. Okay, so if x equals a is a real zero of f, that is equivalent to saying that a0, this ordered pair, is an x-intercept of the graph of f. Okay, and then hang on, I'll come back to number 3 in a minute. A, which is again an x value, is a real solution to the equation f of x is equal to 0. Okay, so again, if you substitute x equals a, okay, you're going to get that f of a. So if you plug a into the function, you're going to get 0 as your output. Okay, coming back to number 3 here. Okay, if x equals a is an x-intercept or a 0 of your polynomial function, then x minus a is going to be a factor of f. Okay, this is really, really important, and I'm sure it sounds really, really confusing to you right now. Okay, so let me try to explain it to you this way. Okay, so let me come up here. Okay, say we had a quadratic equation. Okay, so say we had x squared plus 7x plus 12. Okay, this is a quadratic function. The highest power of x is 2. It's a polynomial. Okay, every quadratic function is a polynomial. Okay, so what happens here, okay, back in the day, we said, okay, what if I wanted to, this was actually section 4.3. Okay, what if we wanted to graph the function? It's going to be a parabola. And we said we had to find the vertex and then we had to find the x-intercepts. Okay, to find the x-intercepts, which would be the zeros in this situation, we had to recognize that f of x is the same thing as y. Okay, to find the x-intercepts, we need to set y equal to 0 and solve for x. Okay, so if we do that here, if we set y equal to 0, okay, this is what we get. And now we need to solve. Okay, so to solve a quadratic equation, you either factor or you use the quadratic formula. Regardless, one side has to be 0 before you start. We do have one side equal to 0 already, so we can go and factor the non-zero side if we do this by factoring. Okay, this is going to factor into x plus 3, x plus 4. Okay, and you can check it if you multiply it back out. You should get x squared plus 7x plus 12. Okay, so again, we're after the x-intercepts. Okay, we're factoring to get there. Okay, once we've factored, we need to take each factor, which are the things we're multiplying together, set them to 0 and solve. Okay, so one factor is x plus 3, set it to 0. The other factor is x plus 4, set it equal to 0 and solve. Okay, so you're going to get two x-intercepts here, -3 and -4. Okay, So let's use this example to try to translate number 3 right here. Okay, so remember, these statements are equivalent. Okay, if x equals a is a 0 or an intercept. Okay, so this is what it's saying. Okay, if in this particular situation, okay, x equals -3 is an x-intercept. Okay, because we solved for it. Okay, we solved this particular quadratic function and we found it has two x-intercepts. I'm just concentrating on one of them for right now, the -3. Okay, x equals -3 is an x-intercept. Okay, that's your a value here. So a is -3. Okay, then according to part 3 here, x minus a is going to be a factor. Okay, so x minus a is going to be x minus -3. That's going to be x plus 3. Okay, is a factor. Okay, if you go backwards to where you factored, you see that x plus 3 is one of the factors. Okay, that's how we got the x-intercept of -3. Okay, we took the x plus 3, the factor, we set it to 0, and then we had to move the 3 over, so we ended up subtracting, and that's how we got x equals -3 as an intercept. Okay, so that is what that particular statement in number 3 is saying. Okay, if a is a 0 / x-intercept, that's the same thing as saying x minus a is a factor. That's going to be really, really important. Okay, so we're going to do a lot of practice with it. Okay, all right. Okay, so next thing. Okay, just keep in mind these things are equivalent. They all mean the same thing. Okay, a polynomial function f of degree n has at most n real zeros. Okay, so if you have a polynomial function, okay, let's go back up to the quadratic example. Okay, if you have a polynomial function that's a quadratic, okay, let me write this down here. Let's say down here, quadratic. Okay, so we know that a quadratic function is a polynomial of degree 2. Okay, usually we use n for degree. So what this is telling you is that any quadratic function that you encounter, it is going to have at most 2 real zeros. Okay, so any quadratic has at most 2 real zeros or intercepts. Okay, so think about it. Okay, I'm going to draw some rough sketches. Okay, there's 3 possibilities here with a quadratic. Okay, your quadratic can have 2 x-intercepts. Okay, so you've got one here and one here. Okay, so you've got 2 x-intercepts or zeros. Okay, we have seen a quadratic that basically has 1 x-intercept. Okay, it just touches the x-axis in one spot. Okay, so in this situation, this particular parabola has 1 x-intercept or 1 0. Okay, it's possible that your parabola has no x-intercepts. Okay, so this one has 0 x-intercepts. Okay, or zeros. Okay, so what this statement is saying is that if you have a polynomial function of degree 2 in this case, that means it can have at most 2 real x-intercepts or zeros. Okay, that means it can have 2 x-intercepts, it can have 1 x-intercept, or it can have none. Okay, so if you had a polynomial function of degree 6, okay, it may have 6 x-intercepts. It may only have 5. It may have 4. It may have 3. It may have 1. It may have, well, sorry, did I skip one? It could have 6, 5, 4, 3, 2, 1, or 0 x-intercepts. Okay, it can't have 7. Can't have 8. If it's degree n, it can have at most n real zeros. Okay, why does it keep saying that word real? Okay, real zeros or real x-intercepts means we can physically see them on the graph. Later in this chapter, unfortunately, we're going to deal with imaginary numbers. Okay, if it's imaginary, you can't see it. So we are going to encounter imaginary zeros. Okay, you can't see them on a graph. Okay, that's coming up. All right, last thing about zeros here, it says to find the zeros of a polynomial, use factoring. Okay, that's what we're familiar with. We are going to talk about something called the rational zeros theorem and synthetic division. So in some cases you may have to go that route. So don't freak out about that. I'll explain it to, when we get there. Okay, but for now, just stick with factoring to find your zeros. Okay, here's why. If you have degree 2, that's quadratic. Yes, you can use factoring or the quadratic formula, but remember the quadratic formula only applies to degree 2. So if we're going to be working with higher degree polynomials, meaning degree 3, degree 4, and higher, okay, there's no quadratic formula, okay? You have to rely on factoring, okay? And then if that doesn't work, that's when this rational zeros theorem and synthetic division is going to kick in, okay? All right, so make sure you read through this information again about zeros because it's kind of confusing, okay? But practice is going to be the best way to learn this.